End of chapter problems here. We'll go with the number 16. Write an equation that shows the formation of a rubidium ion from a neutral rubidium atom. E equals 37. So we're looking at rubidium. The formula for rubidium is Rd. And so if we're going from rubidium, the atom to the ion, we're going from rubidium, and what's the charge on the rubidium ion? Plus 1. And so that leaves an extra electron. That extra electron, which we call E minus, goes somewhere. And so this would be the equation for that. Usually, you know where that extra electron goes? The extra electron goes to some other atom to make an anion, like chlorine. So rubidium chloride, the rubidium metal would give up an electron to a chlorine atom from rubidium chloride. Let's take a look at 18. Next, 18, what are the names of O2 minus and I minus? O2 minus would be oxide, and I minus? Iodide. Okay, then we're off to number 20. What are the formulas for tin 4 ion? Tin 4, the symbol for tin? Sn, Stanium, Sn tin, and tin 4 has got to have a 4 plus charge. Here I wouldn't use a Roman numeral, let's use a regular number here. So Sn4 plus would be tin 4. What's the other one they're asking for? Manganese 2. Or manganese 3? Okay. A lot of people confuse manganese with magnesium. Magnesium's Mg, manganese is Mn. Manganese 3 would just be Mn3 plus. What are the names of Pb2 plus? Pb2 plus is called, is it fixed charge or variable charge? Pb is plumium or lead. Roman numeral. The next one there, CO, cobalt. Cobalt's variable charge. This one happens to have a charge of 2. So it's Roman numeral 2. Okay, next. What are the formulas for lithium nitride? So lithium nitride, that's an ionic compound, it's metal and non-metal. And so we have the lithium cation. Lithium, fixed charge or variable charge is fixed charge. Lithium is going to be what? 1+. Now nitride, the D tells me this. It's nitrogen, 3 minus. He's monatomic. There are some, like hydroxide, but there's no element in hydrox. So lithium nitride, how many lithiums are we going to need? 3. We need 3 lithiums. That's going to give me Li3 and lithium nitride solid. Let's see, what's next here? Chromium 2 chloride. So chromium 2, right here, and chloride's fixed charge. So how many chlorides do we need? 2. It's just CrCl2. Another solid, chromium 2 chloride. Aluminum phosphide. Aluminum is fixed charge at +3. Phosphide, the IDE ending tells me it's monatomic with a charge of 3 minus. So this is fine, ALP. Tin 4 bromide. So again, stanium or tin 4, this is 4 plus, and bromide is a minus. So how do we balance out the charge here? we're going to need 4 bromides to balance everything else. So SNBr 4. Tin 4 bromide. Tin is on the border, close to the border. So sometimes people will call that tin tetrabromide. You know. Yeah. All right, let's go on to number 24. What are the names of MnF3? What's MnF3? Figure out the, well, I know manganese. Manganese is variable charge. That's a +2 or +3. But fluoride's fixed charge, so we can figure it out. How many fluorides do we have? 3. So if we have 3 fluorides, the charge on manganese has got to be +3. That's the only one that would work. So this is going to be manganese, Roman numeral 3, fluoride. Manganese 3 fluoride. Okay, the next one, NiS. Nickel's variable charge. I know your book says it's fixed charge at +2, so it's actually variable charge. Sulfur is fixed charge though. Sulfur has got the charge of 2-. Therefore, nickel must be plus. So this is going to be called nickel, Roman numeral 2, sulfide. Now, if you consider, our book's just going to call it nickel sulfide. It's okay. By far, the +2 state on nickel is the most common. The next one is a little bit tricky because of the PbO2. You know, it might be O2 2-, it might be a peroxide, or it might be 2 O2-. It might be an oxide. So is it a peroxide or an oxide? Well, let me tell you, peroxides are pretty unstable, and so they're pretty rare. So we always go with the oxide, unless it's impossible to go with the oxide. And so if we go with the oxide, then lead's got to be, lead's got to be 4+. And so this is going to be lead 4 oxide. And that's what it is. It's lead 4 oxide. What's the next one? CO2S3. So cobalt is variable charge. So I don't know what the charge is, but I do know what the charge on S is. So we have 3 S's. Each S is 2-. So the net negative charge is -6. So the net positive charge has to be +6. So it's going to be cobalt +3. And so this is going to be cobalt, Roman numeral 3, sulfide. See it? All right, now I haven't talked about oxoacids yet, so let me talk about oxoacids now. Or actually, not just oxoacids. I want to talk about all acids, not just oxoacids. Oxoacids, you know what oxoacids? Oxoacids are going to have anions that end in AT, E, or ITE. The T is for oxygen. But I want to talk about acids that have anions that end in D. So, acids in general. Naming acids is easy. It just depends on the anion. The cation's always the same. The cation is H+. The anion is the only difference. So always H+ here. And so the only difference between acids is what the anion is. And so the name of the acid is always going to be based on the anion name. We only have 3 distinct endings for anion names. What are the 3 endings for anion? Well, we'd like look at the anion name, we only have 3 endings for anions. What are the 3 endings for anions? We have I, we have 8, and we have house. So the basically it's going to go like this. To figure out the acid name, for example, if it ends in I, what we do is we add the hydro prefix and the ate acid suffix. So let me give you an example here. The classic example would be something like HCl. How would you name this? Well, yeah, we have the chloride, so that's chloride, and therefore we call it hydrochloric acid. Hydrochloric acid. This is why, actually, let's see. If it ends in 8, all we do is we just change the ending to ic acid. So what ends in 8? Give me an anion that ends in 8. Any anion that ends in 8. Borate? You want to go with borate? All right. Borate is, what's the formula for borate? BO3, and the charge is 3 minus. So how many hydrogens would I need to balance out? 3 hydrogens. And so it'd be H3BO3. And so the anion's borate, therefore the acid will be called boric acid. And lots of examples. The anion acetate gives us acetic acid. Chlorate gives us chloric acid, etc. All right, if the anion ends in "-ous", actually, let me do one more. So, for example, here, if I do HClO4, ClO4, do you recognize that one? No, but it's chlorine and oxygen. And so I know chlorate. Chlorate has how many oxygens? Chlorate has 3 oxygens. This has 4, therefore it's called perchlorate. And so the anion is perchlorate. If the anion is perchlorate, then the acid will be perchloric acid. So if we have "-ous", an anion that ends in "-ous", then we call it "-ous acid. Or no, sorry, not "-ous". Anions don't end in "-ous". Anions end in "-I", "-ate", or "-ite". If the anion ends in "-ite", we call it "-ous acid. Sorry. And so let's do something like this. Let's look at HNO2. NO2 is nitrite. If NO2 is nitrite, then we call the acid nitrous acid. Let me do one more example here. HClO. ClO is called hypochlorite. So we just go down the list, you know. If perchlorate is ClO4, actually we go with chlorate. If chlorate's ClO3, then ClO2 is chlorite, and ClO is called hypochlorite. And so if this is hypochlorite, then the acid name is going to be hypochlorous acid, hypochlorous acid. acids have an H. There's only one. That's how we recognize acids. They all begin with an H. So, what element is present in all acids discussed in this chapter? Hydrogen. 28. Which of the 5 memorized ic acids? Okay, your book has a different technique for naming acids. Your book asks you to memorize a certain number of acids. I don't think it's necessary. We don't have to memorize anything. We just do this. Go back and forth. And so I'm going to skip your book's method. I'm not even going to talk about it. All right, let's go with the first set here. HCl. HCl is a super common acid. It should be automatic. That's called hydrochloric acid. Chloride goes to hydrochloric. Okay, the next one is nitric acid. So now we have to work backwards. If we have an ic acid, then we're dealing with an A. And so what is nitrate? Well, nitrate is based on the periodic table. How many oxygens does it have? 3. And what's the charge? And so, yeah, this would be nitrate. And therefore, nitric acid, we just add an H. How many H pluses do we need? Just 1. So the formula is HNO3. Nitric acid is also a super common acid. Hydrochloric acid and nitric acid, very common. All right, what's the anion here? PO4. Well, we know the charge. You know, it's going to be PO4 3 minus, which is called phosphate. So it's 8. We go to ic acid, and so you would like to call this phosphoric acid. The phosphoric acid sounds funny, and it's not historically accurate. This has always been called not phosphoric acid. This has always been called phosphoric acid. So sometimes the name is modified a little bit, and so officially this is called phosphoric acid, based on phosphate. Hydrosulfuric acid. Now, if we have hydroic acid, hydroic acid means sulfuric acid must contain the hydrosulfuric acid must be ide, yeah. And so that means sulfide. It's got to be sulfide, right? Hydrosulfuric acid must be sulfide. And here again, there's a little bit of modification to the name. Because officially you'd call it hydrosulfic acid, but hydrosulfic acid sounds funny. And so they call it hydrosulfuric acid. And so the hydrosulfuric means sulfur acid. So it's S, it's got to be an I, so sulfide is what? S2 minus. And so how many hydrogens do we need for that? 2. And so hydrosulfuric acid is H2S. Hydrosulfuric acid, not many people call H2S hydrosulfuric acid. Most people call H2S hydrogen sulfide. And most people recognize the odor of hydrogen sulfide. Do you know what hydrogen sulfide smells like? Hydrogen sulfide smells like rotten eggs, you know. And so, you know, if you breathe in rotten eggs, it's hydrosulfuric acid or this. Let's go on to the next one. HNO2. Let's see, we want to erase that one. NO2 with a -1 charge. What's the name of that? nitrite. And so it's an ite, which means rather than calling this is nitrite, and so we'll call HNO2 nitrous acid. So this is nitrous acid. Hydroselenic acid. So we got the hydroic thing going again. And so that means it's got to be selenide, right? Selenium, selenide. And so what is the formula for selenide? Well, selenium is Se. Yeah, it's 2 minus. And so we'll need 2 H pluses, which is going to give me H2SE, which is hydroselenic acid, aka hydrogen selenide, which also smells very bad. HClO4. HClO4 has the anion ClO4 minus. We just saw that one. Yeah, that's called perchlorate. And therefore, HClO4 must be called, well, it's ig. Perchlorate gives it the ig acid. So it's going to be perchlorate acid. We have perchloric acid. Hydroiodic acid. Hydroiodic. So we got the hydroic going, so it's got to be I. It's got to be iodide. Iodide. Iodide is what's a charge and what's a symbol? I minus. And it's going to be formula. So what did you get the formula for hydroiodic acid? HI. That would be hydroiodic acid. Okay, HClO2. So we got to figure out, it's going to be ClO2 minus. So what's the name of ClO2 minus? Well, this is chlorine with oxygen. So chlorate is ClO3, this must mean it's chloride. Chloride. If this is a chlorite ion, an ite, so HClO2 must be chlorous acid. That's correct. Selenic acid. Ic acid. Selenic acid. Selenic acid must mean we have selenate. Selenic acid must mean we have selenate, but we got to figure out what is selenate ion. Well, if you know silicate, then we know phosphate, we know sulfate. What is sulfate? SO4 2 minus, and then selenate's right below, so it's got to be SeO4 2 minus. And so how many hydrogens do we need? 2. So the formula for selenic acid will be H2SeO4. Selenic acid. HBrO2. BrO2, I know BrO3. BrO3 is called bromate, and therefore BrO2 must be bromite. Bromite means it's bromous acid. HBrO2, bromous acid. And I guess this is blank here, so how many more? Practice there. So just some more practice naming ions. What is the formula of arsenate ion? Arsenate. Arsenic is right below phosphorus. So we know what phosphate is. What is phosphate? PO4, 3 minus. Therefore, arsenate would be ASO4, 3 minus. So arsenate should be ASO4, 3 minus. Just like phosphate. What are the names of TeO3 2 minus and IO3 minus? TeO3 minus. Te is called tellurium. And tellurium is right below what? Selenium. And so, what are the 8s? Well, we got sulfate. Sulfate is SO4 2 minus. Selenate, which is SeO4 2 minus. And tellurate. Tellurate should be TeO4 2 minus. So if I know tellurate is TeO4 2 minus, then but we don't have TeO4. They're asking TeO3 2 minus. So if I know that this is tellurate, then when we go to TeO3 2 minus, this has got to be tellurite. So we go 8 to ite. Ite is 1 less oxygen, same charge. So this is tellurite ion. Uh-huh.
If you said hypotellurate, would it be the same thing?
No. If you said hypotellurate, then it would be the same thing as tellurite.
That's something.
Because hypo would be 1 less oxygen.
Yeah.
But what should you call it? Should you call it hypotellurate, or should you call it tellurite? You should call it tellurite, because we have the 8 ite. And so the only time we use the hypo is when we're down at the bottom here. There's no other, and so we got to use the hypo. So hypotellurite would be, okay, and then what would pertellurite be? Pertellurite would be tellurate, so there's no reason to call it pertellurite. But we could have pertellurate, which would be TeO5 with a 2 minus charge, 1 more oxygen. IO3 minus. IO3 minus, that should be easier because this is just iodate. IO3 minus is iodate. 3 oxygen. All right, what are the formulas of zinc nitrate and calcium selenate? What is the name of this one? Okay, so let's go with zinc nitrate first. Is zinc a fixed charge or variable charge? Well, zinc is Zn. Is it a fixed charge? It looks like it's in the fixed charge region. Let's take a look. Yeah, it's here. So this whole region is variable charge, right? Except for zinc, cadmium, and silver. So it goes 2, 2, 1. And so zinc is fixed charge. You just have to have that one memorized. Zn2 plus. It's in group 2B. Nitrate. What's the formula for nitrate? Nitrate we just get off the periodic table. You know, borate has how many oxygens? 3. Carbonate's 3 oxygens, nitrate's 3 oxygens, chlorate's 3 oxygens, chlorate, bromate, iodate, all those are 3 oxygens, right? And so nitrate's 3 oxygens, but what's the charge? The charge will be -1, because it goes 3, 2, 1, right? The pattern goes 3, 2, 1, 1, 1, 1, 1. And so looks like we need more nitrates. How many nitrates do we need? 2. And so when I do this, I have to be careful. So is that right here? This is not right because it looks like I have 1 nitrogen, 32 oxygens. That's not what I want. I want 2 nitrates. So I need parentheses here. We always write parentheses if there's confusion. We don't write parentheses if there's no confusion. So for example here, NgCl2 does not need parentheses here because there's no confusion. That's 2 chlorides, 1 magnesium. And so only write the parentheses if confusion arises. Okay, calcium selenate. Ooh. Calcium is fixed charge. What's the charge on calcium? Plus. Now, what the heck is selenate then? Well, selenate we can get off the periodic table again, because we know this. You guys memorize silicate. How many oxygens on silicate? 4. So all of these have 4. Phosphate's 4, sulfur's 4, germanium 4, arsenic is 4, selenium is 4. So it's got to be SeO4. But what's the charge? Yeah, so it goes 4, 3, 2. So this is 2 minus. So it's balanced. We just need 1 of each. Do we need parentheses here? No, we don't need parentheses. There's no confusion. 1 calcium, 1 selenate. No parentheses are not required. Okay, the next one's a little bit tricky. I know BrO2. BrO2. Have you memorized NH4? Ammonium. And so NH4 is just a memorization thing, ammonium ion. And then BrO2, what the heck is that? BrO2, there's got to be a minus charge because ammonium's a positive charge. So BrO2, bromide. So it's bromide. Therefore, we call this ammonium bromide. That would be the name of this one. Ammonium bromide. Now, there's more ions, more anions, but these anions are easy to derive. These ones are called acid anions. So let's talk about things. If we have sulfates, then if we add an H+, we'll have HSO4. If we add an H+, do you know what the net charge is? H is positive, sulfate's 2 minus, so this whole thing is going to be -1. If we add another H+, then we have what we'll call an acid, H2SO4. H2SO4 is called, well, it's based on sulfate. So what do we do with the 8 ending? Sulfuric acid. Sulfuric acid sounds funny, so they changed it a little bit and call it sulfuric acid. This is sulfate. This is what we call an acid anion, this species here. There are two names for this. One is just called hydrogen. This has got a hydrogen ion attached to a sulfate. And so we call it hydrogen sulfate, a hydrogen ion attached to a sulfate. It's HSO4 minus. Or bi with a B, sulfate. Bisulfate. And so this goes, you can go both ways. Let's look at this one. You recognize this one? CO3 2 minus is called carbonate. If we add an H plus to this, we'll form HCO3, but the charges don't balance. It would be -1. If we add another H plus to this, then we get H2CO3, the acid. H2CO3, what's the name of that acid? Carbonic acid. Carbonic acid. Do you know what the acid anion's called here? This one's simply hydrogen carbonate or bicarbonate. Hydrogen carbonate or bicarbonate. All right, write equations for the first and second steps in the step-by-step ionization of selenic acid. Ionization means to break it apart into ions. So this is just going backwards from what I wrote. So let's start off with selenic acid. What the heck would the formula be for selenic acid? Selenic acid means I have the, what? I, 8, or else. I'm going to have the 8. Are we out of time? I'm going to have the 8. And so what is selenate? SeO4 2 minus. And so how many H pluses do I need? 2. So selenic acid is H2SeO4. Selenic acid. What they're saying is, in ionization, we're breaking it apart to form ions. And so when we break this apart to form ions, it goes one step at a time. We break off one H plus, and that leaves us with an HSeO4 minus. And so the first hydrogen breaks off. Then we're going to break off the second hydrogen. When we break off the second hydrogen, then altogether we're going to have 2 hydrogens and a SeO4 2 minus. And so we call this one selenate. What do we call this one? Hydrogen selenate or biselenate. So pretty simple. Pretty simple. So, this one's not so simple though, number 38. So let's take a look at number 38 really quick. Number 38 is a bit more complicated because of this. We could go either way. What's this called? PO4 3 minus. Phosphate. And so if we add just one H plus, we'll have HPO4 2 minus. If we add a second H plus, we'll have H2PO4 minus. If we add a third H plus, we'll have H3PO4. H3PO4 is called phosphoric acid. Yeah, and so this is called phosphate. Now we have 2. We can't call both of these hydrogen phosphates. Otherwise we might get mixed up. And so the first one we call monohydrogen phosphate. And the second one we're going to call dihydrogens. We don't use the bi here. There's no biphosphate in this case. Otherwise it'd be confusing.
But it's still considered an acid, though, right? The H.
Yeah, it's still considered an acid, and so it's going to have all acids have H plus in them. And so even though would be the acid proper, these are still what we call acidic because they have H plus, and so they still can act as acids. Chemical.
So it's water and acid, you know?
Yeah, water is an acid. Water is a very unique one. Water can act both as an acid and a base. Normally when we think of water, it's pH neutral. And so when we drink water, we don't think we're drinking acid, right? But water can act as an acid, too. We'll talk about the chemical properties more later. But I think we're out of time now, is that Dan? So we'll stop now, and then we'll just finish up this chapter 6 tomorrow.